So good afternoon, everyone. I hope you are all doing well. And just a little bit about myself. I work as an analyst in observation team, looking after pre-processing observation in BUFR. And also I'm a chair at the expert team on data at the WMO level. So anything related to BUFR, please just reach out and we are happy to help. So just let's start with the presentation. And let me just then share my screen and then we can start. So first, what is BUFR? BUFR is a binary universal format for representation of meteorological data. It is governed by the World Meteorological Organization, and all about format you can find at the manual on codes, and that is provided at the link on the slide. BUFR is a binary format and it's mainly used for a representation of meteorological observations, synop temps, satellite data, aircrafts, marine observation, and it is a table-driven code. It means that all what you need is the tables. And the tables are maintained by WMO. Within that group that looks GRIB and BUFR and recently NetCDF. So BUFR is a BUFR message is actually bit stream. It's just a stream of zeros and ones, and they are like divided within sections, and each offset in that section is the 8 bits. ecCodes library that's developed at ECMWF includes BUFR tables, so you don't need to worry about that if you are using ecCodes library. And BUFR format, there are main 4 tables that are used by the definition of the format. It's table A, that is like the table that contains data categories. That's the categories of a data, like satellite, radar, surface, marine, or some phenomena like tropical cyclones. Then table B, that's the list of all BUFR elements, or in ecCodes world, we call them keys. So that's just like elements, like temperature, pressure, wind, or any other related to satellite, radar, oceanographic observation. And that also related to the number that is defined in table B. Then table C, it's a list of operators. BUFR is defined in a way that you can change the definitions of the elements through operators. You can change the range of the values, or there is some operation that gives more precision to the data, or some attributes that explain data a little bit better. And table D, that's like BUFR common sequences or templates. That is just a grouping of all BUFR elements related to specific data type. So if you want to represent synop observation, then you will have dedicating template that represent all elements to report synop observations. Or if you have some data from specific satellite and instrument, then you will group all elements defined in table B under the table D BUFR sequence that describe that data. And that's good to do because it's easiest for the user. They can go to the manual on codes and search for the common BUFR templates or sequences for representations of specific data, and then it's useful for user to understand the structure of the data. So, as I mentioned before, BUFR messages are divided in sections, and one BUFR file can contain one message or several messages. Depends how the data providers are encoded data. So buffer message has 6 sections. The section 0, that is indication section, section 1 identification section, and the section 2, which is local section, that's the section locally used for each center. And we call them in like a header information. And then buffer, in section 3 and 4, in section 3 you have a list of data descriptors, that's the list of elements or the dedicated buffer template. And in section 4 is just data section, all that bits 0 and 1s. And section 5 is the end of the message, and that contains that 4 7s. So if you look a little bit deeper in section 0, you can find that keyword buffer, that is the start of the message. You can find there the length of the message and buffer edition number. So the latest is the buffer edition 4. In section 1 is the identification, give you information about length of the section, and also provide information about the buffer tables used to encode the data. And that is important because you need that also to decode it afterwards when you receive data in buffer. You can find there information about originating center and subcenters. So that's the centers who actually encoded data into buffer. Data category that is related to the table A that I mentioned before, the category of the data, and then you have international data subcategory that's defined deeper, more information about like a generic data category. You have here the numbers of the master tables. Latest one is 44, and the local tables, that's the local tables related to the centers who provide data. They can encode buffer messages using their local definitions, and then if you get the buffer that contains local tables data, providers should provide that to you to be able to decode the buffer files. Also there you can have information about year, month, day, hour, a second, and minute. And then, as I mentioned, section 2 is the local that defines for each originating center that could be used for internal purposes like pre-processing or archiving. And how that section 3 and 4 look in a buffer world. So here you have like a list of the numbers. Behind all these numbers is either the buffer element, which start with a 1, and then follow with other numbers. And all that is then related to the real world, like temperature or wind speed. And then if start with a 3, that means that like a buffer sequence or template, it means that is the list of all elements related to the specific data type. So when you encode the buffer message or when you decode it, you will see that under unexpanded descriptors, that's the list of all elements you will see in your buffer file. And then in data section, you just have a stream of 0s and 1s. But to crack all this, you need a library to read and make a meaning of all these set of all 8 numbers into the real value. So how buffer elements are defined? So for example, this one is latitude, and in buffer B table, it's under this number 5001. 5 is the class, meaning that so in a buffer you have like elements divided in classes. Each class has a name. You can find it on internet. Some of them are for identification, some for instrumentation, some for satellite data. And then code is just start from 1 to 191. And then it's like assign that numbers for specific elements. Here I put latitude as a key, ecCodes key. You already heard about ecCodes library. And you can find that under the ecCodes documentation, the list of all ecCodes keys. And then definitions is for each element you have units, scale, reference, and width. Scale gives you precision of the element, and width is allocate how many bits is needed to encode the value related to altitude. That's determined like a 2 to the width minus reference, which is the maximum value you can encode to that variable. And buffer template does the list. Like here I just have a buffer template that's like defined with this number and the list of all elements related to that template. Okay, so now I just wanted to show you how you can decode the buffer messages using ecCodes. So, and I just prepare here the notebook for you to walk you through about how you can do that. So first, when you get the buffer file, you can use that buffer _ls -p, and then you can specifically ask for master table version, followed by your buffer file, and that will return the number of the master tables. And you need to secure that you have that tables on your system, so because then you will be able to read the data. Then you can also should check if that buffer message is encoded using some local tables, and you can obtain that information using that buffer _ls -p, followed with the center. This is the keyword, and then local tables version number, followed by your buffer file, which gives you information. For example, I just put it here that the center that encoded the message is ECMWF, and the local tables version number is 0, meaning that that we didn't use any local tables to decode this buffer message. But if you have any other number, then you need to look at the definitions under ecCodes to find out if you have that. And then you can use buffer _dump -p, follow your buffer message, and then you have a list of all elements in that message. That buffer dump is actually encode your message on the screen. And I just here put example of the file that I look at, and then you can see here first is the header information for this specific file. And the meaning of all these data categories, international subcategories, you can find on the WML links that I provided on the slides. So you can see here master table 39, meaning that you need ecCodes version that contains that number, and here is the 0 local. That doesn't mean that is not use the local tables to encode the data. So then here you have unexpected descriptors. That's all descriptors used to encode this buffer message. And I just want to show you how you can, I mean, this is nice to use buffer _dump to explore your data, but in operations, you need to write a program to handle buffer messages. And here is example how you can do that in Python and using ecCodes. So first you will import all libraries you would need to work with. And so you import ecCodes, and just for this exercise, I decided I will use NPRA and pandas. Then I develop here the function that will read my buffer message. First, in my definitions here, I have a method that will read my buffer message, and the input to this function is the file. Output would be your buffer message object, that you will use to each library calls functions when you read other elements from this message. So here I use with open that save me to not close the file at the end, because that does for you. And then I open it as F. Then I will call this function codes buffer new from file. And then I will get that buffer message object. Also, it's good that you check that you actually obtain the buffer object and raising some error message so you can handle it. And then this method will return that buffer object. Now I have a method that decode the buffer message, and the input here is that buffer objects. And I will return dictionary that contains all decoded data. So when you work with ecCodes, you need to first unpack data, meaning that you can use code get to get the values of the headers. But if you want to get the values from the data sections, where is your data, you need to use that keyword unpack with this call. And then after that, you will be able to encode the values from the buffer message data section. So here I just want to show you how you can do that. So this you need to call codes get. You put like your buffer object, then your key for ecCodes. You can find that keys related to the message using that buffer_dump. And then you just passed all these calls here. And then I wanted to get the values of the date, then latitude, longitude, wind direction, and wind speed. That is in my message. And then I will return data as a dictionary. Then how I will run all this, I will specify the path to my buffer message. Then I will call the method passing this file to obtain this buffer object. I will pass that buffer object to this my decode buffer message method, and then I can actually convert all that to data frame. It's nicer to print. And then at the end, I need to remember to call codes_release with that buffer object to release that when I open that message to release it. So, and when I run all this, I will have information from this buffer file. And then you can have a look here that in your buffer message, you can see here wind direction %confidence. And what is that? That is actually bitmap. So I can show you here how this buffer message look like. So I have information about the station, then date, then location, and I have wind direction and wind speed. But then this my buffer message actually contains additional information to these variables, and that is presented using bitmap. How you can realize that is working about bitmap. When you dump your message, you will have this block here. And then these 2 to 2 zeros mean that quality information will follow. Then you will have 236, which means define data present bitmap. Then this one means that you replicate one element 4 times. Every time when see this is replication, And then this 031 is data present indicator that is defined with zeros or ones. And then you have percent confidence that relates to the specific element in the message. How do you know which element contains percent confidence?
In the background time.
So you can have a look at the data. Buffer dump will print that for you, but for you to understand, if you get bitmap that's the defined like this, it's saying like one element 4 times. That relates to this data represent indicator. So you have that 4 times, meaning that is like mapping to these 4 elements, because bitmap is always coming from backwards, from definition, going from the end of the message to the top. So this relates to the last 4 elements. And then how do you know that that percent confidence is applied to specific element, meaning when element related in that third place here, it's wind direction, meaning that more information about confidence of that measurement is applied to wind direction. And then how you can actually access the value of that percent confidence in ecCodes. You can do that using this operator, like wind direction. Then you have that operator with arrow, percent confidence. And using that codes underscore get, you will get that value. So yeah, I just here explained the same what I show you there on the slide. And you can also decode the values of the data present indicator using this function called gets. Then you put your buffer object and this key data present indicator. And for the message that I looked at, that was the output. Yeah, and then that's it to understand about bitmaps. And if you have a big file you need to decode, then there is a very nice feature of ecCodes that you can do that like with the buffer underscore dump, followed by minus capital D Python, then your buffer file, and then you can redirect to the Python program that gives you like a sample of program to decode the message. And you can use that and adapt for your operational need. So I will stop here, and if there are any questions now, I can answer quickly before we move to content that Roberto prepared for you.